I welcome you all for this presentation. In the last presentations, we have discussed about mail security, then web security, and in this presentation, we are going to discuss IP security. This is the overview of this presentation, that is introduction to IP security, then IP security architecture, then IPSec services, then transport and tunnel mode in IP security, then security associations, then encapsulating the security payload, then IP security key management, then IP security payload and exchanges, then cryptographic suites, followed by summary of this presentation. And we have discussed about PGP in the mail security. So here we are having many security mechanisms. So far for the last 2 or 3 presentations, we are discussing about the security in various aspects with respect to mail, then web, then file, transport layer security. Many things we are discussing, and here we are going to discuss about the internet protocol security. This is mainly based on this network security because internet protocol is in the network layer. So it is mainly based on this only. So we have specified a many range of applications specific to security mechanisms. Say for example S-MIME, but S-MIME we have not discussed because that is in the PGP, but it is not covered in the syllabus. So we didn't discuss about S-MIME. But PGP, Kerberos, SSL, HTTPS and all we discussed. However, there are security concerns that cut across protocol layers. You know the ISO OSA reference model. Base is the physical layer and the top is the application layer. And we have discussed some of the application layer securities. Then we have discussed about the transport layer security. Now we are discussing about the network layer security. That is the IP security. So we have to secure all the applications in the network as well. Then the general security mechanisms provides for the authentication, then confidentiality as well as the key management. All the security mechanisms in the first unit we have discussed many security mechanisms. All the security mechanisms we are applying with respect to all the layer protocols in all the layers as well. And these IP security mechanisms are applicable to use over LANs across public and private WANs and for the internet. And we need to perform some authentication and encryption in IPv4 as well as IPv6. So you know the header format of IPv4 as well as IPv6. There is some variation in this IPv4 and IPv6. So how to perform encryption with respect to IPv4 as well as IPv6 and how to authenticate the internet protocol, that only we are going to discuss here. These are some of the IP security uses. So how it is connected, where we are using the internet protocol, that you have to know. So here you see this public internet or private network is there, and in each and every system we are getting user system with IPSec, that is we are getting each and every packet must consist of IP header, then IPSec header, then security IP payload. So here in each and every packet we are having some security mechanisms incorporated with that. So wherever one packet is traveling, there here we are sending the IP header, then IPSec header is there, secure IP payload is there in all places from Ethernet switch to the networking devices with IPSec. Here you see Ethernet switch with networking devices with IPSec, and this networking devices, whether it is an edge router or something else, if it is connected to the internet, the large public or private network, there also we are incorporating this IPSec. So the benefits of IPSec includes it is used in a firewall or router that provides strong security to all traffic crossing the perimeter devices. Then in a firewall or router is resistant to bypass some of the security mechanisms. So there also we are providing this IP security concept, and this is below the transport layer, hence transparent to applications, and it can be transparent to end users as well. IPSec can provide security for individual users. Then it secures the routing architecture. Then coming to the IP security architecture, we are having many specifications, and each and every specifications are complex, and they are grouped into some groups, that is with respect to the architecture, then with respect to the authentication header, with respect to the encapsulating security payload, then with respect to internet key exchange and cryptographic algorithms. Then other category also we are having many IP security architecture. At each and every IP security architecture are made as a standard. So only for each and every IP security architecture there is a RFC. See, RFC 4301, RFC 4302, RFC 4303, then RFC 4306. For each and every category of IP security architecture, standard is available, and if you want to know more detail about these architectures, you can please refer these RFCs. Next, IPSec services. Here we can have the access control, then connectionless integrity, then data origin repudiation, then rejection of replayed packets. That is, it is a form of a partial sequence integrity. Then confidentiality means encryption is applied, then limited traffic flow confidentiality. All these terms you are aware of that. Whatever the terms you know about these things, that is applicable with respect to the IP security as well. Next is the transport and channel modes. These are new for you. So here you see transport level security. In the last presentation only we have discussed about the transport level security. So here we are having the transport mode as well as the channel mode. Transport mode is to encrypt and optionally authenticate the IP data, and it can do traffic analysis, but it is efficient and it is good for ESP, encapsulating payload, that is called as ESP host to host traffic. So here you see that is a general transport level security. Here we are having the systems are connected to the internal network as well as the external network. And here if a session is created, that is encrypted TCP session is created. Why we are performing encryption? In order to maintain confidentially among the transport messages. For that only we are performing encryption. Then we are exchanging or creating a session in order to have the communication. So mainly one of the main services with respect to IPSec is confidentiality. So only we are having the encrypted TCP session. And here you see a virtual private network via the channel mode. So let us see what is a channel mode. Then we can see this. So this channel mode encrypts the entire IP packet. Here we are adding a new header for next to hop. Then no routers on way can examine the inner IP header, and it is mainly good for VPNs, gateway to gateway security. So only this channel mode is virtual private network via channel mode. This channel mode is used in this VPN network. See, here we are having a corporate network. Corporate networks are connected with the internet, and here we are having the encrypted tunnels carrying the IP traffic. Tunnel, generally, tunnel means one pipe like that of thing only. What we call in general tunnel, the same concept only here also it is applicable. So it encrypts the entire IP packet, and a cover is made of that, and it is sending, so that we are getting more security using this transport and channel nodes in the IP security. Next is the transport and channel mode protocols format. See here, generally in the ISO-ISA model, IP, then TCP application. See here below IP, we are having the IPSec. Because in order to provide more security, we are having this IPSec. So here you see the data is encapsulated with many things. TCP header. So generally in the IP means we are having the data plus TCP header, and original IP header is there. Here in the IPSec, in addition to this TCP header and original IP header, we are having the encapsulating payload header, then encapsulating payload trailer, then encapsulating authentication as well. So these things are included in the transport layer. Coming to the tunnel mode, IP, then IPSec, then IP. So tunnel, some extra covering is there. So inside we are having the security part, outside we are having IP. So here how the data format is available compared to transport mode and tunnel mode. In the transport mode we are having data, then in the IP as well as in the IPSec we are having this format. Here you see the same in IP. In IPSec we are having whatever format available in transport mode. Again we are having IP. There you see the same thing available with respect to new IP header is there. So the tunnel mode protects in a efficient manner, so that only we are having IPSec above and below the IP we are having the IPSec, and inside that security is provided and outside it is covered with the IP. So only it is more protected. The IP is secured in a very efficient manner using this tunnel mode. The security associations involved in this IPSec, it is a one-way relationship between sender and receiver that affords the security for traffic flow, and it is defined by three parameters, that is the security parameters index, then IP destination address, as well as the security protocol identifier. And here we are having number of other parameters also in addition to these three parameters, that is the sequence number, then AH and EH information, then lifetime, etc. And it have a database of security associations. So here we can represent what are the security parameters associated with IPSec, that we can represent using different parameters. Each and every parameter is have some specific meaning and specific way of usage. The security policy database relates the IP traffic to specific security association. So it matches a subset of IP traffic to 11 security association, and it uses selectors to filter outgoing traffic to map based on local and remote IP addresses, the next layer protocol, name, local and remote port. See here the format, the protocol, local IP, port, remote IP, port, action and command. For each and every protocol we are having different actions as well as the command. Please go through this. Next is the ESP. In all places we have seen encapsulating security payload. Not encapsulating payload, it is encapsulating security payload. So it provides message content confidentiality, then data origin authentication, then connectionless integrity, and it is providing an anti-replay service with limited traffic flow confidentiality, and the services depend on options selected when established security association net location is there, and it can use a variety of encryption as well as authentication algorithms. The format for this encapsulating security payload in the format of the transport as well as the tunnel mode, we have seen as a small box as encrypted encapsulating security payload header as well as encapsulating security payload trailer, and authentication is there. So for this encapsulating security payload, we are having a specific format, that is here you see ICV coverage. Here we are having the security parameter index, that only we have already told that some parameters are incorporated. So the security parameter index, then sequence number, then initialization value, it is optional, then rest of the payload data. So this forms the payload. Then TFC padding, then padding, another type of padding, that is optional padding is there, compulsory padding is there. Then here we are representing the padding length as well as the next header. Then we are having the integrity check value, that is the ICV variable. So these things above this integrity check value to the top, we are calling it as integrity check value coverage, and this part we are calling it as a encrypted form. The payload, then padding, all these things are encrypted or given in a encrypted manner. So here it is a encapsulation. Encapsulation means what do you the meaning you know. So encapsulating the security payload. Between we are having the payload, then above and below some covering is there. That is called as encapsulating security payload. So here we can perform the encryption as well as authentication, and in the encapsulation security payload can encrypt the payload data. Then it padding is added so that we have to represent the pad length and the next header fields. And if needed, because in the initialization vector it is given as optional, so if needed we have initialization vector at start of payload data, and ESP can have optional ICV for integrity. In the last part we have the optional ICV is computed, and it is computed after encryption is performed, and ESP uses padding. Why padding is needed in this ESP means to expand plain text to required length and to align pad length and next header fields. It is also to provide partial traffic flow confidentiality, because encryption, wherever you are hearing the word as encryption, it is providing confidentiality. If we need to provide any confidentiality for the information or whatever the thing we are using in the network, then we can go in for the encryption process. Next is the anti-replay service. That it is a replay when attacker resends a copy of an authenticated packet and it is used sequence number to thwart this attack. That is, the sender initializes sequence number to 0 when a new SA is established. So here we are incrementing this value for each packet, and it must not exceed the limiter 2 power 32 minus 1, and the receiver accepts packets with the sequence number within the window. So the calculation for finding the size is n minus w plus 1. Next is the combining the security associations. We have a security association, then we have to, in order to provide more security, we have to combine the security association. So this SAS can implement either AH or ESP, and it is to implement both need to combine SAS. How we are combining means it form as a security association bundle. We are combining it, so it is acting as a bundle, and it may terminate at different or same endpoints. It is combined by transport adjacency and iterated tunneling. So how we are combining, why we are going in for combining the security associations means in order to provide both the confidentiality as well as the authentication. For that only we are bundling everything, and here we are combining authentication as well as encryption. So in order to provide authentication and confidentiality, we are combining or bundling the security association. So ESP with authentication bundled inner ESP, and outer AH bundled inner transport and outer ESP. Here different scenarios are there, and I already told you tunnel. See here, tunnel inside the whatever the thing we are going to secure, outside many layers are there. That forms a tunnel. In order to give more security, we are having this tunnel. Next is the IPSec key management. It handles key generation as well as the distribution. Typically, we need 2 pairs of keys, 2 per direction for AH as well as ESP, and it is a type of manual key management only. So system admin manually configures every system. We are also having the automated key management, that is automated system for on-demand creation of keys for SAS in large system. Here we are having 2 elements, Oakley as well as ISA KMP elements. Let us see those elements, what are they. First is Oakley. It is a key exchange protocol. It is mainly based on Diffie-Hellman key exchange. You already know what is Diffie-Hellman. It is base for the public key crypto system, and it is the foundation for key exchange algorithm. So here it is a key exchange protocol, no, right? Oakley is a key exchange protocol, so it is based on Diffie-Hellman key exchange. Add some features to address the weaknesses in the Diffie-Hellman key exchange also. There is no information on parties and man in the middle attack is there. So it adds some cookies, groups, nonces, DH key exchange with authentication. It can use arithmetic in prime fields or elliptic curve fields. Why it is performing the arithmetic in prime fields or in elliptic curve fields means in order to provide more security. While exchanging the key, we have to provide more security. For that only, it is using the arithmetic in prime fields and elliptic curve fields. Next is the ISA-KMB. ISA-KMB means Internet Security Association and Key Management Protocol. It provides a framework for key management, and it defines procedures and packet formats to establish, negotiate, modify and delete SAs. And it is independent of key exchange protocol, encryption algorithm and authentication method. Then this IKE version 2 no longer uses this Oakley and ISM terms, but basic functionality is more or less same only. Because these are the main protocols used in the IPSec. So these are not used means also, but the basic functionality behind these things are more or less same. Some delta increment concept is added in all the cases. So how this IKE V2 exchanges happen means first we are having the initiator as well as the responder. So here the information is exchanged. First initial exchanges are there. So initial exchanges, first initiator is sending to the responder, then a responder is sending reply to the initiator. Likewise, first we are just providing the, in order to provide authentication, first we are having the initial exchanges. Then we are creating a child of security association exchanges. There also we are sending from initiator to responder and responder to initiator. Finally, only we are exchanging the information. So if we need to exchange some information, first need to have some initial exchanges, then we have to create child of this service association, then only we have to exchange the information. This is the format of the ISA KMP. that is IKE header format. Here we are having the initiator security parameter index, and here you see it is represented in bits 0 to 8, then 16, 24, 31. So totally the size is of 32 bits. Next we are having the responder security parameter index. Next we are having the next payload, then major version, then minor version, then exchange type, flags, then message ID, as well as the length. In the generic payload header, we are having, this is also of 32 bits only. We are having the next payload, then C reserved, as well as the payload length. This is the format of ISA KMP. Next, IKE payloads as well as the exchanges. It has a number of ISA KMB payload types. That is, we are having the security association, then key exchange, then identification, then certificate, then to provide certificate request, authentication nonce. In order to notify some messages, we are having this type. Then delete, vendor ID, traffic selector, then encrypted configuration, extensible authentication protocol. And the payload has some complex hierarchical structure and it contains multiple proposals with multiple protocols and multiple transforms. These are some of the cryptographic suites. That is, we are having different cryptographic algorithm types to promote interoperability, and we are having different RFCs. That is, RFC 4308 defines VPN cryptographic suites. That is, VPN A matches common corporate VPN security with using triple DES and HMAC. Most of the techniques we have discussed that is used in this IP security. Then VPN B has stronger security for new VPNs implementing IPSec version 3 and IKE version 2 using AES, Advanced Encryption Standard. Then RFC 4869 defines 4 cryptographic suites compatible with USA NSA specifications. That is, it provides choices for encapsulating security payload and IKE, AES, GCM, AES, CBC, HMAC, SHA, ECB, ECD, SA. But some of AES, then AES cipher blockchaining, then HMAC, SHA, most of the things we have learned. So wherever in order to provide authentication, we are using the hashing algorithms, and in order to provide confidentiality, we are using the encryption algorithms in the cryptographic suites. So these things are mainly to improve the security of the internet protocol. In this presentation, we have discussed about introduction to IP security, then IP security architecture, then what are the services available in IPSec. Then main thing is transport as well as tunnel mode. Then we have discussed about the security associations, then encapsulating security payload, then IPSec key management, payload and exchanges. Finally, we discussed about the cryptographic suites used for this IP security. Thank you.